Okay, so we're talking once again about parallelograms. And in our last lesson, we talked about the definition of a parallelogram. And then today we're going to be talking about some properties. And it is important in the next math classes that you can know the difference between the two, between a definition versus properties. So, for example, the definition of a parallelogram is a quadrilateral with two sets of parallel sides. That's like the minimum requirement for something to be considered a parallelogram. So this definition is looking at the minimum things that have to happen in order for it to be considered a parallelogram. But once I know it's a parallelogram, then I can know that all these properties are true. So for example, the properties I'm talking about, opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Once we know something's a parallelogram, we know all these things to be true. So let's talk about a couple statements, if-then statements, and then what would be the converse of that? What could I say about it in reverse? So I'm going to use the text box here. Number one is given to us fully done, so we can see an example. If I'm talking about the property of opposite sides are parallel, the statement would be, if a quadrilateral is a parallelogram, then it has opposite sides. So we're going to go down to number two, and we're going to make the if-then statement. If a quadrilateral is a parallelogram, then it has opposite sides that are congruent. So do you see how I'm taking the statement that was given to us, the property that was given to us, and then we're turning it into an if-then statement? Now, I think I'm going to shorten this a little bit. I'm going to just say it has congruent opposite sides, so it fits better on that line, okay? So same thing, has opposite sides that are congruent, or it has congruent opposite sides. So we're now going to go make the converse statement of this. Okay, so we could say that the converse of this would be, if a quadrilateral has congruent opposite sides, then it is a parallelogram. Do you see how I'm basically going to take the back part and flip it with the front part? If a quadrilateral has congruent opposite sides, then it is a parallelogram. So it's basically reversing the statement above. And that's how we get to a converse statement. It's basically reversing the if-then statement from the beginning. Okay, so we're going to go do this on all of the rest. If you want to pause the video here and go try it out. Otherwise, I'm just going to work through these here. And these are called if-then statements. We're going to start with, if a quadrilateral is a parallelogram every time, then it has congruent opposite angles for this one. So we're taking that property and we're putting it into an if-then statement. Looks like I'm going to need to go down on the font here a little bit to make this work. And then we're going to reverse that. If a quadrilateral has congruent opposite sides, opposite angles, then it is a parallelogram. So again, we're taking the original if-then statement and we're reversing it. And this is called the converse. If a quadrilateral is a parallelogram, then it has supplementary consecutive angles. And then in reverse, if a quadrilateral has supplementary consecutive angle, then it is a parallelogram. And finally, if a quadrilateral is a parallelogram, then it has diagonals that bisect each other. And our converse of that is if a quadrilateral has diagonals that bisect each other, then it is a parallelogram. Okay, so writing if-then statements from the properties and writing the converse of those, which is basically just reversing the if and the then parts. Okay, now let's use the converse statements to complete the list below. So go take a peek here. How to prove a quadrilateral is a parallelogram. We can use the converse to prove that something is a parallelogram. So we could use the converse by showing that both pairs of opposite sides are parallel. So if we can show that both pairs of opposite sides are parallel, we can say it's a parallelogram. If we can show that both pairs of opposite sides are congruent, then we can say it's a parallelogram. If we can show that both pairs of opposite angles are congruent, then we can say it's a parallelogram. If we can say that the pairs of consecutive angles are supplementary, then we can say it's a parallelogram. If we can show that its diagonals bisect each other, then we can say it's a parallelogram. And finally, this is a little key one here. If we can show one pair of opposite sides is parallel and that one and congruent, and I'll show you what this looks like in a picture here, then we can say it is a parallelogram. So here's what this one would look like. Let's say that I have a shape, that looks like a parallelogram. Actually, let me draw it down here with that statement. Sorry guys, this is looking pretty bad. We think it's a parallelogram, we're not quite sure. This is saying that if we can show that one pair of opposite sides is parallel and congruent, if it's parallel and congruent, then we know that it is a parallelogram. And that definitely will be on the quiz, so be prepared for that one. Now let's use the converse statements from the above list to complete this down here. Follow these steps to find the value of x. So starting with the equation for angle A and angle D, we can see that the measure of angle A, look up here, is equal to 120 degrees, and the measure of angle D is equal to 3x. So we write that angle A is 120, and that measure of angle D is 3x. Since we know that the measure of angle A and the measure of angle D equal 380 because they are consecutive angles that are supplementary, we can say that 120 plus 3x is equal to that 180. So then we're going to minus 120 from both sides, leaving us 3x equals 60. Divide both sides by 3. We solve and get that x equals 20 degrees. So if x is 20, the measure of angle D is 3 times 20, or 60 degrees. And then the measure of angle A, we're double checking it, 120 plus 60 does equal 180. Check. And that's the end of our study guide. Actually, because it's so short, I'm just going to go straight into the checkup. So here we go with this next one. Find the value of x that makes these true. Do you see already that 12 and 12 are matching? There's my two opposite congruent sides. So the other two sides are congruent. So we're going to set those to equal. 4x is equal to 18. And you can leave this as 9 halves, or you can actually grab a calculator and divide 18 by 4, and you get 4.5. So you can leave it as a fraction or a decimal. And then next, see the 10 and the 10. So I have to say that the other two sides are equal. 1/3 of x is equal to 7. How would I solve that guy? Multiplying both sides by that denominator. We get that x is equal to 21. Finally, over here, there's the 20 and the 20. So we've got see how this over here got cut off? Hang on, let me check my book and see what that number is supposed to be. All right, that's supposed to be an x plus 4. Sorry about that. So we're going to say that x plus 4 is equal to 15. And then we solve for x, and we get 11. Okay, so again, pause the video, see how many of these you can get on your own, and then check to see how you did. So here we're solving for x. Well, we've got opposite angles are equal. So 2x minus 97 is equal to x plus 4. $97, $98, $99, $100, $101. And then the two side angles are supposed to be supplementary to that. So for us to fully get one of the measures of those angles, we would have to take 101 plus 4, and that makes 105. Or we would have to take 101 times 2 and then minus 97. Do you see how I could plug that x in to find that alternative value? So if we are searching here for an x, this is one way to do it. Another way to do it would be to take 75 plus 2x minus 97 and make that equal to 180 because those consecutive angles are supplementary. So you also could have solved it making it equal to 180, and that would also be correct. So for this next one, again, you can choose to do the opposite sides are congruent, or you can choose to do the supplemental equals 180. I'm going to do opposite are equal. So I'm going to go x plus 20 is equal to x plus 20. And if I subtract the x and then I subtract the 20, do you see how it just gives me 0 equals 0? So in this case, this one didn't help me solve. So I'm going to use the supplementary concept. So 3x minus 98 plus x plus 20 equals 180. I'm making these two add up to 180. The consecutive angles are supplementary. So 3x and 1x is 4x. Negative 98 plus 20 is negative 78. We're going to add 78 to both sides. Let's do that on a calculator just to be safe. 180 plus 78, getting 258 divided by 4. I'm getting that x is equal to 64.5. Okay, how'd you do? So see how I tried to use the same method as the one before and it didn't work on this one? I had to use the supplementary part. Okay, finally, I've got these two angles here. Let's try the supplementary. Let's say 3x plus 28 equals 180. Those are the consecutive angles that are supplementary. Remember, consecutive means next in line or right next to. We're going to minus the 28 from both sides. 180 minus 28 is 152 divided by 3 gives me 50.67. And because I'm rounding here, I need to make this an approximation symbol. Okay, again, keep pausing the video for you to go try some of these on your own. Go ahead and try the next one. I'm going to write the work down here below. So I'm going to use on number 7, opposite angles are equal. We're going to say 5x is equal to 50. So x equals 10. And same on the next one. You could use opposite angles are equal, or you could use consecutive angles are supplementary. Your choice. Here I'm going to get 5x plus 125. And then subtract 125 from both sides. All right, on this next one, I'm also going to use consecutive angles, x plus 10 plus 78, supplementary. These two are supplementary. And so that's x plus 88, subtracting 88 from both sides. Over here, I'm going to use opposite angles are congruent. Now, remember how to get rid of this 2/3? I'm going to do something called multiply by the reciprocal. It's multiplying by 3 and then dividing by 2, so I can get rid of it in one step. So the top is 112 times 3 over 1 times 2. So 336 divided by 2, I'm getting that x is equal to 168. How'd you do on solving these parallelogram angle measures?